Hello everyone, my name is Mr. Burke. I teach statistics at multiple community colleges across Southern California, and I am making this video, as I do with other videos, to provide clarification on topics that students often find confusing. And one of the challenges my students face is, when do I use the addition rule? When do I use the multiplication rule? What are the differences between the circumstances? So we're going to talk about that in this video today, with a real emphasis on language, because statistics, unlike a lot of other math courses, has a lot of language in it, and we need to look for certain key words that will help us to better understand not only when to use what application, but how to read the questions more effectively generally, so that we can do our work within each of the rules correctly. So first thing I want to talk about is, in the comparison of these, we need to define what an event is in statistics. And an event is defined as any collection of results or outcomes of a procedure. And I like to think of it usually in the context of outcomes, because if we think about what an event is outside the context of statistics, we know that an event like a baseball game, it can have two different outcomes. So one event can have two different outcomes, for example. Like if you have the New York Yankees playing the Philadelphia Phillies, either the New York Yankees are going to win the game or the Philadelphia Phillies are going to win that game. So, that is one event, two different outcomes. So we know that an event can have multiple outcomes. When we're looking at both the addition rule and multiplication rule, these are used for different sets of circumstances. So the addition rule is used for one trial, and the multiplication rule is used for multiple trials. So that's going to be important to know, because we're going to look for keywords in the question that tell us when are we looking at one trial or when are we looking at multiple trials. Because what students confuse when they look at this is, what's the difference between multiple trials and what are multiple events? Because in a question where you apply the addition rule, you can have multiple events, or like you can have multiple outcomes, and you can have multiple events, but it's still just one trial. So the number of trials that are occurring is the key difference between when we apply the addition rule and the multiplication rule. So we'll take a look at example problems here in a bit where we provide that. So in the addition rule, we consider the probability of one trial. And in that one trial, we sometimes have multiple events, sometimes we don't have multiple events. Okay, sometimes it's just one event. But we're going to apply the addition rule when we have multiple events. Otherwise, we can just calculate the probability of one trial and one event without issue. The multiplication rule is utilized when we have multiple trials, and we want to consider the probability of multiple trials. So that's a key difference between these two. Now, under each of these ideas of the addition rule and the multiplication rule, there are two different ideas which students also confuse. The idea of whether events are mutually exclusive. So what we're talking about is, the mutually exclusive rule talks about the possibility of events, like if the outcomes of these events have anything in common. And if the events that are possible have completely different outcomes, we say they're mutually exclusive. If they have any outcomes that are in common, then we say no, they are not mutually exclusive. So let me just provide a little example of that to give that a little better context here. So I'm going to go ahead and move this up a little bit. And by the way, guys, you'll find that I use paper here because my writing on the computer screen is not the best. So just to give an example here, so let's say if I roll a six-sided die, I want the probability of rolling an odd or an even number. Okay, and I want to know, are these events mutually exclusive? So let's just look at the sample space for an odd number. So the sample space for this is going to be 1, 3, and 5. The sample space for rolling an even number, the sample space for this is going to be 2, 4, and 6. Okay, so the sample space for the event of rolling an odd, the possible outcomes of this event of rolling an odd are 1, 3, and 5. Okay. The sample space for the outcomes of the event of rolling an even number are 2, 4, and 6. If we compare the sample spaces, we'll see that they have no numbers in common. Therefore, we can say that these are mutually exclusive or that these events are disjoint. Okay? So remember, the probability of rolling an odd or even, okay, this is what we can regard as a trial. Okay? What does the trial contain when we're calculating this probability? These are each events. So odd and even, these are each events. What is in the sample spaces? The sample space represents the possible outcomes of each event. Okay? So what we have inside here are the possible outcomes. All right? And because we can compare the outcomes and see that the outcomes have nothing in common between each of the two events, we can say that these are mutually exclusive, or the other word that you may see in your textbook is the word disjoint. All right, so this is an example of two events that are in fact mutually exclusive. So what is an example of an event that's not mutually exclusive? So let's take a look at here. I'm going to use the sample of the die again. So let's say I want the probability of rolling a number that is even or prime. So this is my trial. Okay. And what are the events? The events are rolling an even number. So what are my even numbers? Okay. What are my outcomes here? My possible outcomes for the event of rolling an even number are 2, 4, and 6. Now, what are the outcomes for the event of rolling a prime number? So those outcomes are 2, 3, and 5. So in that instance, what we find is when we compare these two events, there is in fact one outcome that they do have in common, which in this case is going to be 2. And because of that, we can say that these events, that these two events that we're looking for in that probability, these events are not mutually exclusive. They are not disjoint because they have, these two events have this one outcome in common. Okay, so as a statistician, because we understand this kind of intuitively, or we understand this very thoroughly, it can be easy to sometimes misuse a word here. So we talk about finding the probability of a particular event, of a particular trial here. We refer to this as a trial. These are the possible events here. And we take a look at the possible outcomes of each event to occurring. All right, I hope that clarifies that idea about being mutually exclusive. So remember that when we're talking about the addition rule, we're talking about one trial. When we talk about the multiplication rule, we are talking about multiple trials. And we're not looking, and when we're looking at the multiplication rule and talk about the idea of independence, we are not considering if outcomes, if these trials have the same outcomes. What we're looking at is, does the first trial, what occur there, does it impact what can happen in the second trial? Okay, so if the first event, or the first trial, the probability of that trial, impacts the probability of the second trial, then we say that they're not independent. So are they independent? If the probability of the first trial does not impact the probability of the second trial, that usually with replacement, then yes, they are independent. They are not independent when the probability of the first trial impacts the probability, or if the probability of the first trial impacts the second trial. Now, let me add a little clarification to this. We say they are not independent if the first trial, if what occurs, if the first trial, what occurs in the first trial impacts the probability of the second trial, meaning there's not replacement. So let's go to an example where, yes, they are independent. And what I'm going to go with is 5 marbles in a bag. So let's say I have 5 marbles. We'll have 3 red and 2 blue. And we'll have the red ones be like the empty ones, and then the blue ones be filled in. For the purpose here, because I don't have multicolor markers. And here's going to be my bag. I'm going to go ahead and move this up a little bit so that everyone can see this. So here's my bag. So let's say for this question, I want the probability of picking a blue marble the first time and a blue marble the second time. And I'm going to say this is with replacement. So the first time I pick, the probability of picking blue, well, that's going to be equal to, how many blue do I have? 2. How many total do I have? I have 5 here. So the probability of picking blue the first time is going to be 2 over 5. I go ahead and replace it. So for the second pick, I still have 2 blue marbles. I still have 3 red marbles. So the probability of picking blue on the second pick is going to still be 2 over 5. So because this probability has not changed at all, we can say that these two events are going to be independent of each other. Or these two trials are going to be independent of each other. We sometimes use the word trials and events independently when we talk about probability. Okay, let's take a look at an example when we say no, that these two trials are not independent. Okay, so same picture here. Okay, so I'm not going to draw it again, not at least for the first one. So I want the probability of picking, let's say, red this time and red the second time. This is going to be without replacement. So the first time, for the first pick, the probability of picking red is going to be, let's say I have 1, 2, 3 red marbles, then 2 blue, so it's going to be 3 out of 5. Okay, but for my second pick, let's draw the picture of what we have here because we no longer have replacement. I only have 2 red marbles and I have 2 blue marbles. So the probability of picking red, that's going to be equal to 2 over 4. So when we compare how many, how the first probability, what the first probability is, and then the second probability is, we see here that that these probabilities are not equal to each other. I should probably round that down to 1/2, because in the first trial we did not replace that, so we removed one of the marbles. So that not only impacted the number of red marbles we have, being 2 here, but it also impacted the total number of marbles that we have. So because we did not replace, the outcome of the second trial is, or the probability of the second trial is different than the probability of the first one. So we can say that these events are not independent. In my next video, I will talk about, show some examples of each of these so that we can see these in context.